Okay, so this video is about error. Okay, so when we talk about error, you should know that we have the precision, and precision actually is used for to have something to measure. Okay, so for example, for this one measured value, you can see that it's almost 7. So when we say precision, so we have 7 cm. So that you know that it is either 7 or 8. So obviously this is 7, but why? Okay, so first of all, you should know that what is the meaning, okay, of maximum error. So now you can see that for each interval, this is 7 and then 8. So the interval will be 1, okay? And the maximum error will be actually 1/2 of this interval. Therefore, 1/2 times 1, which gives you 0.5. Okay, so for the upper limit, okay, will be this value plus, okay, plus the maximum error. And then for the lower limit, that will be the -1, okay, the -1. So you have 7 minus 0.5, okay? So now let's look at the relative error. By definition, that will be the measured value to be the denominator, while the maximum error will be the numerator. So you have this one, 0.5 over 7. Okay, so this is the relative error. And the percentage error will be this one, relative errors, times 100%. Okay, so next, if we look at, okay, another one. Okay, now if we have 0.5, okay, so the measured value, you can see that this one will be 7, and then this one will be 7.5. So do you know that what value is it? So maybe when you zoom in, you can see that this is almost 7 as well. So the measured value is still 7. But this time, the maximum error will be the precision, that means the interval, multiplied by 1/2. So this will be 0.5 divided by 2, which is 0.25 cm. Okay, that must be the unit. Okay, that must be the unit. So the true value, the upper limit, will be this one. So you have 7 plus 0.25. And then for the lower limit, will be here. Okay, the lower limit will be here. Okay, is it here? Can you see it? 6.75. So basically it is equals to 7 minus 0.25. So again, for the relative error will be the maximum error over the measured value. So which is 0.25 times 0.25 over 7 equals to 0.0357. So for the relative error times 100%, which will give you the percentage error, like this. Okay. So I showed you one more example, okay, for 0.1. So now you can see it. Okay, this time each interval will be 0.1. So obviously this one will be 7.2. Okay, 7.2. So what about the maximum error? This time 0.1 divided by 2, so this is 0.05. So the upper limit will be this value plus 0.05. Okay, and then this value minus 0.05 will be the lower limit. Okay, so that is why you should know what is the meaning. You have the region like this. And then for the relative error, this is the numerator, this is the denominator. Therefore, you have 0.05 over 7.2. Okay, so as you can see it, each time when we change the relative error, okay, how do we change it? We change the precision. So pay attention to this value. Okay, pay attention to this percentage error for comparison. 0.6944% for 0.1 precision. 0.5, you have 3.5714. Precision 1, this is 7. So basically, you should know that when you increase the precision, the error will decrease. Okay, the error will decrease. So I hope that after this video, you know that how do you do, okay, this kind of problem. Basically, okay, find out the measured value, find out the maximum error, find out the upper limit and lower limit, and then find out the relative error as well as the percentage error. That's it for the video. Thank you for watching.